Welcome back everyone from the quick break. I hope you enjoyed the expo. I'm really looking forward to hearing all the next talks coming up. Please do remember to share your highlights on social media using the hashtag YouSTEMMattersConf and tag in at YouSTEM2030. But without further ado, let's introduce our next speaker. Our next speaker is Dr. Kristen Thorson. Dr. Thorson serves as Vice President of Quality and Process Improvement at Regenesis, where she manages and evaluates their company-wide quality processes and continuous improvement activities to ensure consistency and reliability in product quality, performance, and service. Prior to this role, Dr. Thorson served as the Vice President of Research and Development for Regenesis and Land Science, where she led the development and implementation of many numerous products and technologies. Dr. Thorson is an inventor on several issued patents and is a frequent speaker at scientific industry events. Thank you to Regenesis for sponsoring our research conference today, and to Kristen for talking to us about the science of clearing up groundwater. I would like to welcome her to the stage now.
Wonderful. Thank you so much, and thanks for the opportunity to talk today. I'm excited to have a chance to tell you about my company, Regenesis, and some of the work we do to clean up polluted groundwater. And then also end with telling you how I ended up working for Regenesis. So to start, I'd like to just talk a little bit about groundwater. I think sometimes, we are used to seeing lakes and rivers and oceans, but groundwater, because we can't see it, we don't always think about it a whole lot. But it's really important that we do. And that's because, over almost all the water, the liquid fresh water on Earth is actually housed within the groundwater. And so if you or I started digging down below wherever we are right now, we would eventually come to groundwater. Some cases we might only have to dig a little ways to get there, and sometimes we might have to dig really, really deep before we get to it, but it is there. And most importantly is that for almost half the world, groundwater is the source of domestic use water, so drinking water, what we use to clean and bathe in and stuff. And for some countries, all their water comes from the groundwater. So it's really important. We have to be really conscious of keeping it clean and keeping it safe so that we can continue to use it and continue to drink that water. Now, of course, the issue is that there is some groundwater that has been contaminated or has been polluted. And a lot of that pollution comes from things that happen just nearly every day around us. So this illustration gives some examples of where pollution might come from. So example, landfills, we dump our garbage. There are some bad chemicals that will eventually leak through and get into the groundwater. Associated with farming, if there's a lot of fertilizer or pesticides, sometimes if there's too much use, those will eventually run off and end up in our groundwater. And again, of course, the issue is if that ends up going into a drinking water supply where people are taking, have a well to actually remove water and drink that. Obviously, there can be health issues, safety issues there. This is just a few examples of how water can be polluted. I'm sure you can think of others. Feel free to put that in the chat if there's other ideas or things that you know of how water gets contaminated. But this brings up the question of, well, what can we do? Again, groundwater is really important. How can we fix it, or how can we remediate it? And that's what we do at Regenesis every day. We're always thinking about different ways that we can actually go in and clean up this groundwater that's been contaminated. And there's lots of different ways that people do this, but the way we do it at Regenesis is something called in situ remediation of groundwater. And what that really means is that we actually are bringing a solution, bringing the fix directly to the problem. So we're actually, injecting the solution into the ground in order to actually remediate the groundwater. I like to think of it as giving the ground a shot. So just like you might go to the doctor and get a shot in your arm, we're giving a shot into the groundwater to clean it up. So you might be wondering, well, what does this look like? How does this actually happen? So this is an actual site that I was at a number of years ago when we were developing a new technology and trying it out. We'll go out to a site, we'll be at the surface, and we'll have this little drill rig that you can see there that can actually push a pipe down into the ground it's a hollow pipe. And you can't really see, but there's some hoses there that are connected back into this trailer back here. And in that trailer will be some kind of reagent, something that can actually help clean up the groundwater. And so we'll drill down into the ground to reach the groundwater, and then we can actually start pumping these reagents into the ground. So to give you a little bit better illustration of what I just described here, again, you can see the drill rig here, and then here's an illustration of down below us getting into the groundwater. So again, you drill that pipe down into the area that you want to be in, and then you start pumping the reagent into the ground, and it distributes within the groundwater you get in contact with those pollutants that you're trying to fix, and then they will start to do whatever they're going to do to remove or destroy those contaminants. I'll talk a little bit more about what that might look like in a second. And so obviously the goal here is to get clean water. So if everything has gone correctly, you can see in this kind of illustration here that, so again, here's a pollutant moving into the groundwater. Groundwater does have it's kind of like a slow moving river, so there is a direction to it. And if we inject one of these reagents, it will move through that, and the idea is that the clean water will come up on the other side. And we can actually take samples of that water and show that it no longer has the contamination in place. And so what are we actually injecting here? What's the type of things that like we at Regenesis have? Well, it really depends on what the type of pollution is. So if you think back to that illustration early on of the sources of contamination, we're going to match up whatever we are injecting to something that's going to be best suited for that type of pollution. So whether it's gasoline, whether it's the pesticides, there's something called PFAS that you may have heard of in the news that's getting a lot of attention right now because it's a really up and coming pollutant that we're finding everywhere. So we're going to look at what type of pollution it is, and we're going to match our reagent appropriately to something that's going to be able to actually affect that pollutant. In some cases, if you've taken chemistry class recently, it might be a chemical oxidant or a reductant. What that really means is we're going to inject something into the ground that can directly destroy or start to break apart that contamination. Another way that we can actually clean up groundwater that's really neat is that there's a lot of bacteria or microbes that are actually able to get rid of these contaminants. They metabolize the contaminants, or another way to say that is that they really can eat the contaminants and get energy from that. And so sometimes those bacteria are already present. Sometimes we can actually add them to the ground if they're not there, and they will do the work of cleaning up the pollutants. And in many cases, those bacteria need a little bit of help. So for example, there's bacteria that can clean up petroleum or gasoline, and they really need oxygen. But in the groundwater, oxygen can become depleted quite quickly. So one thing that we will sometimes inject into the ground is a material that actually releases oxygen over time so that it can keep helping the bacteria do its job of cleaning up the groundwater. And then we also sometimes inject sorbents. These sorbents will absorb the pollutants and prevent them from keeping spreading in a wider area. So that way we can keep the contamination contained, and we're going to keep a lot more groundwater safe that way rather than having it keep spreading over time. So this is an example of what we do. Obviously, one thing that's really important and one thing that we think about when we're developing this is that we want to make sure that they're very safe. We're actually trying to clean up the groundwater, and so what we put in the ground obviously has to be safe and effective. So a lot of times we use things that are same things that are used in food, because those are going to be something that's quite safe to be actually injecting into the ground. So most of my time at Regenesis has been spent with the research and development group. And our goal is always to make or improve these reagents that we're injecting into the ground. And where we start is in the lab. We go in and we test and we formulate and we make sure that they're going to work. And sometimes we're trying to make them work faster for a longer period of time. We're making them easier to get into the ground. Or maybe we're trying to develop something new that's going to treat a new class of pollutants. And so this is some examples of what we'll do. We'll actually set up these columns that are like mini demonstrations of groundwater, and we can actually test that out in the lab first to make sure they're working and get them just right. We have instruments where we go and we measure the contamination to see how they're working. So this is where it all starts. In one example, one of the first things I did when I joined Regenesis was try to optimize one of our technologies so that it could get into the ground quite readily. So these are tubes that are filled with soil. And again, when we're injecting, we want to make sure it spreads out when we're actually injecting in the ground so we can have good contact with these contaminants. And so this is a time lapse of trying to move some of our reagents through these example soil columns. And this is basically where we started, this one on the right. So this is a powdered activated carbon, which you might be familiar with. And if we don't do anything to it, it doesn't go anywhere in the ground. It just gets clogged up. And so what we spent a lot of time doing, and we ran almost 1,000 of these columns to get it right. We kept changing the formulation, trying to add different things, making the particles a little bit smaller until we got something that actually did move through through the groundwater, through the soil and the groundwater, so that it would distribute really well and it would be more effective. It would do a better job of cleaning up the groundwater at the end. And so this is something that was really, challenging in a lot of ways, but it's something that we worked hard at and were able to get. And now we're using this product called PlumeStop all over the world to clean up groundwater. And, at Regenesis, we've been cleaning up groundwater for about 28 years. So this is something we're really proud of. And again, we're always working hard to try and do it better. And it's a very challenging problem, but we really enjoy it. And so then I'll take the last few minutes here to just answer the question of, how did I end up at Regenesis? And I'll tell you that I definitely did not know when I was going through school about companies like Regenesis. I did not know that this is what I wanted to be doing later on. And I think the simple answer, and a lot of times the simple answer is the best answer, is that I really just kept doing what I like to do. And so I'll kind of walk you through what that looked like for me. So if I go back and I think through this, when I was a kid, what did I like doing? I liked building things. There were examples when there was like a toy that I wasn't going to get, and so I tried to make it myself. That's something that I enjoyed doing. I like baking. I like puzzles. So then fast forward, I was taking chemistry in high school, and I was really enjoying it. And I think I can look back and realize that why I enjoyed it so much is because it checked the boxes. It was something, it kind of matched up all those things that I enjoyed doing. In chemistry lab, you're kind of building things. You're getting to use your hands quite a bit, which is what I liked. It's kind of like baking. You're mixing things together. And you're really solving problems, like when you're writing out these equations and trying to figure out what's going to happen with them. So because I enjoyed chemistry so much in high school, I decided to go to university and major in chemistry. And so that's what I did. And one of the most important things that ever happened is that I took an environmental chemistry course. I still have the book that I had in that course today. But what really I took away from that was that it was just such a cool way to apply these chemistry concepts in a way that, we could write out equations, solve for constants, and also we could understand why the pH of water is the way it is. That just really clicked for me, and it really all made sense for me. So with that, I found something I liked, and I kept doing it. I was lucky to find a professor at my university who did environmental research. He was looking at how methylmercury transports through the food chain, so from water and sediment all the way up to fish. And so I joined him, and one of the best parts of that, something else that I learned that I like to do was field work. So we would go out and we'd collect samples that we would ultimately bring back to the lab and we'd be able to analyze them. So here's some pictures of me out there in these beautiful locations where we would take samples, get to do the hard work, and then go back and analyze them. So I realized I really liked that. So I decided to keep going after university and go to graduate school to get my PhD. Again, I knew I liked environmental chemistry, so I found a group that did environmental chemistry, and I was able to study polluted groundwater some more. Again, I still did not know anything about Regenesis or that there were companies really like this doing that kind of work, but I enjoyed it. So I kept studying polluted groundwater, got the chance to do some more field work, and I also just learned a lot of new chemistry techniques. Just kept learning new things. And so I ended up getting my PhD, and I still didn't really know exactly what I wanted to do. And I guess that's part of my message is it's not always super clear, but you just kind of have to keep going forward. So I decided to keep studying. I did a postdoctoral associate work in Germany where I got to keep studying polluted groundwater. It didn't have field work, and I definitely missed that. But again, I still wasn't really finding that job where I was going to land after this. But one other aspect that I liked during school was really teaching. And so I ended up going on and becoming a chemistry teacher and a tutor for a while. However, I really enjoyed it, but I knew it wasn't what I necessarily was going to do for a really long time. And so I kind of kept looking, kept talking to people, and just kept going on, trying to again find something that was going to match up with what I really like to do. And eventually I found Regenesis and was able to join here and become a research scientist and eventually lead the research and development group. And so, when you think back, that's exactly what I liked doing when I was a kid. I still get to build things, get to solve problems, invent things. And, now we're not just studying polluted groundwater, but we're actually getting a chance to clean out groundwater. And so I think that's one of my messages is just find what you like to do and try and keep going down that path, because what that's going to mean is that you're doing something that you're passionate about, and other people will notice when you're passionate about what you're doing, and it's gonna do good things for you and for others in the long run. So with that, I'll finish up here, and I'm happy to answer any questions. Please reach out to me if there's anything that you'd like to know more about.
Thank you, Kristen, for an amazing talk. It was great to learn about the importance of groundwater and how it can be cleaned. We've had some questions in the chat. Do the types of pollutants in water differ geographically?
That's a good question. Certainly they can, yeah. So there's some pollutants like metals that can get in the ground, and that will change based on what the soil makeup is, and that certainly can be regional. A lot of pollutants do stem from something that happens above ground, and so in that way they don't necessarily have to be regional or geographical, but there are some, and I'll add to it about metals is that sometimes the metals are present, but what happens above ground can actually make them be released, and so that's what happens. So it can be a complicated mix of how these pollutants get there.
And then another question is, what advice would you give your 16-year-old self?
That's a really good question. I think, there's something about make sure you're having fun, make sure you're asking questions. So one thing I will shout out to people is that I definitely am more of an introvert. I didn't like to raise my hand in class. And that's okay. Like, I don't think you have to do that, but I did find a way to ask my questions. If it was going after class, asking a smaller group of people, so I would tell myself, keep asking those questions, keep putting your ideas out there. And yeah, just kind of know that, if you keep going after what you like doing, it's likely going to work out for you.
That's great advice. I would like to thank again Regenesis for sponsoring our event today. I'll now pass over to Tatenda, who will be introducing our next few speakers.